Now it is, great. All right, welcome back for this break. As we were talking about, we were covering what the changes that we made on Sparklyr 05. Just as a quick recap from break, we were mentioning that we used to have a ports file. We replaced the ports file with a gateway socket. That gateway socket provides basically mapping from any R client to the right connection in the backend. We're actually doing great on time, so hopefully we'll have time for questions. We have a couple more slides on changes. So the Livy case is interesting. As I mentioned, with Livy, this is also a feature that got introduced on 05. For those of you that haven't looked at Livy in the past or yet, this is their main webpage, livy.io. It was originally a project from Cloudera, which I believe is transitioning to being a Apache Spark project. And it's basically a REST API for Apache Spark jobs. And it provides also a REPL. So the challenge here was, how can we maintain the same fidelity of comments that you use on Sparklyr with a Livy backend? Since, as I mentioned, we use all the binary streaming, a binary encoding. How can we do that over HTTP and specifically over REST to be interoperable with Livy? So what we do is we use obviously the REST API because that's what Livy provides. It's a REST API, so you need to use that if you want to be able to access a Livy cluster that provides Livy support. So we use obviously the REST API to initialize the Spark application. So that's kind of like the first approach. Instead of you giving us, or you giving a Sparklyr a yarn client identifier for master, you would say, for instance, if you're working against Microsoft Azure, you would say something like hdinsights.azure.com/Livy. And that's just a REST endpoint. So we go to that REST endpoint from Sparklyr. We request a Spark application to be created. It gets created on the backend. That's all great. But then we still need to figure out how to deploy this backend, and especially if we want to have like a concise mapping between working on Yarn client, working locally, or working on Livy. You definitely want to have the same bits on the backend to make sure that whatever you're doing looks the same on whichever platform you are or whichever way you're connecting. So what we do is we basically have a subset of the code base that we also shipped on the package as Scala files. And whenever you connect to Livy, we get these files, which is our whole Sparklyr backend, and we push it through the Livy connection, which basically adds functionality to serialize results, format the results correctly, and things like that. Once we have that backend running on Livy over the HTTP connection, what we do is we basically encode the binary stream into base 64, and we pass everything over HTTP. So it's really the exact same connection that you would get from Sparklyr client from running locally or even on Yarn client. We have the same fidelity by encoding everything as base 64. Gets authenticated if you've set up authentication on Livy, gets passed through the backend, and then the backend executes it in binary format. It gets again compressed back, well, not compressed, but encoded back to base 64, and then we read it. I feel like this was kind of like interesting since it's like a good design that basically provides you support regardless of the medium that we're using to get connected. So for this release, the big change that we have is to support execution of arbitrary R code. And again, this is under development, but it's something that we're planning for this version. The previous slides that we've covered basically take into consideration the top diagram, which is everything was executing on the Spark driver from a Sparklyr perspective. One of the good questions that we got during the break was, do you need R installed on the worker nodes for Sparklyr to work? And the answer is no, as long as you're using the base functionality that we've talked about on this talk, right? So you will need to install the R runtime if you want to use if you want to run custom R code in each worker node, which is a very particular feature that we'll demo, and it will make more sense once we take a look at that. But basically, the way it works, if you want to run distributed R code, the way it works is you have the same backend on the driver node. You have the client, you have the backend, it gets executed. But then the backend, basically, our functions will create an RDD, and then Sparklyr will do its magic, and it will run custom code on the right nodes and do reshuffling and whatever needs to get done in order to get to that computation efficiently. But once we're at the local level where the RDD resides on that particular machine, basically what happens is the Sparklyr backend gets initialized again, and the opposite happens. Instead of R code calling Scala code, the Sparklyr backend executes the R code through the same socket connections that we provision on the driver node. Although it's completely independent, it follows the same architecture, so you get the same type of serialization and the same type of functionality. Obviously, this can happen for multiple nodes. So in this case, in this diagram, we have 1, 2, n, right? 2 in this case, n, whatever. And each node has its own copy of the Sparklyr backend. Each worker node starts the R process and runs custom code there. So yes, this covers mostly all the way to what we're currently working on Sparklyr 06, which hasn't been released. And the last set of slides that I have is I'm going to walk you through some use cases on using Sparklyr with a little more concrete examples. So we'll already touch base on SQL and dplyr. So here's another example, a little bit more interesting than just counting the number of records, which I'm sure didn't impress anyone. So what we're doing here is we have this flights table. I believe this is our data set with about 100,000 or alike, less than 1 million records. That is basically tracking flights coming in and coming out from New York City on the year 2013. So we can ask the question of, well, is the delay of a flight correlated with the average distance that a plane has traveled? So here the tail number is just a group by basically the identifier of an aircraft, which is the tail number. And then we're just measuring the distance and the delay, the average delay of those particular flights. And then we're basically plotting with a library called ggplot2. It's probably one of the best plotting libraries on the R community. So we're going to run this, and basically what we get is it's a plot that maybe counterintuitively from what you would expect, the total distance that flights have or that an aircraft has traveled is not really correlated with delays, or at least that's what we find from this chart. And again, I'm not going to do it again, but you can use SQL. If you're really not into dplyr, you can just use straight on SQL Server. Well, not SQL Server, but SQL syntax against Apache Spark from Sparklyr. Something worth mentioning is we mentioned that Sparklyr supports machine learning functions. Apart from running the models, there's a bunch of helper functions that you can find in Sparklyr. One of my favorite ones is called SDF partition. So usually when you're doing machine learning, you don't want to use all your data set for training purposes, right? So what data scientists usually do is they split their data set into two. And one is the training set, and the second half is the actual test set where you can validate that your model is actually predicting and it's accurate. So we have a function that can do that for you. It's called SDF partition, and it basically returns an object with references to a training set and also to a test set. So gets partitioned for you. In this case, we're running, again, a linear regression. But something that is worth noting is that Sparklyr, it's supported since version 1.6, and we took the decision of implementing all the machine learning algorithms that are available on MLlib on version 1. Starting from version 1.6.0, because we want to make sure that our customers that have already clusters, Apache Spark clusters on 1.6 have access to all the machine learning functionality available on MLlib. Here we have linear regression, but we can also go and create something else. So we can say, it's going to borrow that code and walk you through some of the other algorithms that we have. So we basically have full support for MLlib since version 1.6 that we support on Apache Spark. So you can do, you can do ALS factorization, you can do decision trees, you can do gradient boosted trees, you can do LDA, you can do k-means, and there's the full set is here, multi-layer perceptron. So say that we wanted to do k-means classifications. So for k-means, one of the parameters that we also need is the number of centers that we're going to use in our cluster. Let's see. Centers, if I remember correctly. And we can say that, we're going to use the same two features. We don't need a response vector. We only need the features. And we need the number of centers. I believe that's all we need. And what you get is basically the output from MLlib from running k-means over Spark, Apache Spark. Sorry, I went probably too far on the slides, but basically this is the slide that kind of like mentions what we covered. Machine learning using MLlib with full support of all the MLlib functions since 1.6, and we also support all the way to latest version, currently Spark 2.1, and we will support 2.2 in the next coming weeks. So there's, for those of you that might already be familiar with H2O, it's kind of like it's a different set of machine learning libraries provided by a different company, which also happen to be available on Apache Spark. Going back to the concept of extensions on Sparklyr, there was an extension written by H2O, and the main contributor was Navdeep Gill. And we can also run H2O from Sparklyr using their extension. So what we would do here is we would basically convert the data frame from Spark into the H2O data frame, which gives us an H2O data frame. And then we run, in this case, we're running GLM, but we're not using MLlib, we're using H2O's implementation of GLM. You can see that they actually support a couple more metrics than the MLlib implementation, but this is yet another way of using machine learning in a very easy way from Sparklyr. Another interesting extension, and I think we're doing OK on time. Another interesting extension that got developed by Kevin Kuo. This one has to do with how do you do graph processing using GraphX. And in this case, he's using the project called GraphFrames, which is a grapper over GraphX. But very specific, very particular problem. If you had to do PageRank, if you wanted to run PageRank over a set of nodes in Spark using Sparklyr, what would you do? And this is exactly what we're doing. Here, this particular extension is supported on starting on Spark 2.0. So what I'm going to do is I'm just going to disconnect first. And then I'm going to reconnect using the Sparkly Graphs extension. We're using Spark 2.0 in this case. And we're going to copy a data set of high school friendships that researchers put together a few years ago. So currently, what is happening is basically it's copying the data set into Apache Spark. And then what we're going to do is we're basically going to create a matrix of vertices and edges. And we're going to run PageRank on top of that data frame. So that's the result of running PageRank. You have the source, the destination, and the weight. And you can also look at the actual PageRank values for each of the vertices. This is how the data set in this case looks like. It's basically just source destination pairs for a year where this particular high school group of students had a friendship between them. And I'm sure you can think of more practical use cases for PageRank, but it's just great to have like a good community of extensions that are being developed on Sparklyr to make our life easier. And finally, but hopefully not least, the feature that I mentioned we're developing this release is, I actually changed the slide. Great. What we're developing this release is it's a distributed execution for Spark data frames in Sparklyr. And the example that I had before, I changed the slides a bit, was something like this. We have the iris, we have the high schools table that we just mentioned. And one of the things that we can do is we can say, we can add some randomness to this data set, right? So we could say something like, there's different random functions that you can use in R. So this is an R function. This is, for instance, the give me random numbers following a gamma distribution. And like we can add them together to each column. And then when you basically execute this, what we're getting, it's an error. What is that? Oh, sorry. Yes. Yeah. So we don't want to execute over the whole table. We want to execute over each partition. So that's why we run over X. Let me just retry that. What did I do wrong here? This should be. Do I have this table? Yes, I have this table. Let me just run something first really quick. Yeah, so this is, well, I mean, I won't do something as complicated, but like, forgive me here, like we can just do like, hey, I'm just gonna add number 1 to each of them. Our gamma should actually do what I want. Oh, sorry, yes, obviously. So our gamma takes a couple parameters. So you need to specify the number, some of the ranges. So if you don't do that, when the function is executing in parallel, it's gonna basically output an R error, and that's gonna fail. So you definitely want to, have in this particular case, our gamma with the right parameters. But point taken here, if you output wrong code to the distributed R function, you're also going to get an error, which is good. If you wanted to do other things, like if you want just to take one column, you could, as long as you return a data frame, you would get basically that functionality. You can also rename the columns and say names. I'm going to name this one year name. And you can just get rid of the 1900s if that's not what you want. Anyway, so as long point to take here, as long as you're getting a data frame and as long as you're returning a data frame, you're basically going to be able to execute any R function. Let's see, we can name this year 2009 and run it, whatever. And sometimes I need to spend more time doing. What is that? Yes, correct. Thank you for that. Paste. Much better. So year, whatever, and here we're getting 57. So I'm glad to have someone that can like compile my code before I execute it. That's just great. So yeah, as you can see here, we're basically getting a data frame. We're transforming the data frame, and then we're outputting the data frame. And you have basically full support of all the functions that are provided in base R. One of the work items that we haven't implemented for this release is basically getting all the packages that your closure depends on and shipping them to each of the worker nodes. But one of the things that you can do is, today with the development version, is you could potentially ask your system administrator, so as long as the package is pre-installed on the cluster, you would also be able to use it. But we definitely want to improve on that. So from my side, that's pretty much it. So I definitely want to thank you for hanging out here. And I think we still have some time for questions. If you want to send me a question directly, you can find me on Twitter as Javier Luraschi, or directly at javier@rstudio.com. I'll post the slides on Twitter if you want to grab them from there. You can definitely take the slides and run them yourself. And we might have time for a few questions if you guys want to. Thank you.
So, that's really loud, sorry. So my question is, I typically use Sparklyr to do ETL, create features, aggregate, get the data into a machine learning format, and then pull it onto my local instance to use algorithms that are not available in Spark ML. But I've been working with it for about a year, and whenever I try to collect like about 1 million rows or more, it always fails. Is that something that's going to get addressed and fixed, or what's happening with that issue?
Right. Let me rephrase the question to make sure I understand it correctly. But basically, you're saying that you're using Sparklyr to use ETL and then doing machine learning over it, which...
well, I'm creating the data set into a machine learning format and then pulling it to my local machine or another instance using collect.
Right.
Yeah. But whenever I try to collect like 1 million rows or more, it says Spark backend fails.
What part doesn't work? Like the collection part? Or
yeah, the collection part. Like I can collect like maybe 100,000 rows, but whenever I get like around 1 million, it just always fails.
Yeah, no, that's a really good question in general. So, I think there's two things. Like, well, first of all, like we try to do most of the analysis on. You can do it. I think the answer is basically we want to get better on that scenario. Like there's two limitations that I know of Sparklyr that we want to do better or improve upon. One is when we were looking at the copy to command that basically copies data into a cluster, we know that we have size limitations there, mostly because we're pushing. It was never designed to be, Sparklyr and specifically the command to copy data into a data center was never designed to be a tool to upload big data into a data center. So we know that there's better tools for that. It's mostly a tool to get you started with the helper tables and helper things that you might need to upload into your cluster. And in a similar way, I don't think Sparklyr is optimized for retrieving large amounts of data. So definitely, if you want to open a GitHub issue, shoot me an email and I'll take a closer look. But from the time where we designed these, we basically saw two scenarios, right? When you're collecting data, is like, one is you should never collect data and run your models and do everything on Spark and only collect a subset of the functionality of the resulting model. And the other one is, which I guess might work in some cases, is if your data is small enough, you might want to collect it and run machine learning. But to be fair, like it's something that I haven't really looked into optimizing. But if people like yourself are using it, like happy to take a look, because I know that like honestly we live in a world where it's not really all the time full data or small data, right? Like there's a mix in between, and it makes sense to have good tools that can help you transition between like running things locally on R and running it on Spark. And I think that's a bit of a gap that we could make better. Yeah. Would you send me an email? Like, as you can see, like this has been over heavy development, and I think the best way, like when people ping me and send me an email, I try to bump it all the way up and address it. But one of the things that I'm planning to work on is just the next few months to just work over the GitHub issues and polish the package significantly. But I really appreciate in general like the love and help of the community to just make it better. But yeah.
Yeah. Are you finished? Sparklyr seems to support streaming, at least in 2.3 Spark. It appears that there might be some architectural issues if using Sparklyr with Spark streaming. Is that correct or not? It seems like latency could be a problem. Have you investigated Spark streaming with Sparklyr?
Yeah, so Spark streaming is currently not supported on Sparklyr at all.
I know it's not, but
it's not.
My question is it possible? Or do you have a latency problem?
Well, I mean, everything is possible in the world of open source, right? But I think, honestly, you would have a really hard time getting it to work, and you might need a change on Sparklyr. Let me just show something really quick here. If we go to projects, and again, everything is pretty public and pretty open. There's like a long list of features that we want to get to implement on Sparklyr. One of them is streaming, right? And it's kind of like there. I mean, this is not necessarily a prioritized list, but at least on my mind, that's some sort of priority or urgency that I see on Sparklyr. Spark streaming, it's still on the not yet implemented area. I think you might be able to get some of the functionality with bits and pieces of Sparklyr that are there, but honestly, I think it would be pretty hard. If you find one particular issue that is blocking you, it might be the one that we need to fix in order to enable fully streaming on Sparklyr, but it's currently not supported. So if it works, it would be more of a miracle and less of a design choice to have it working.
Thanks.
Oh, there's a question here.
I don't have much of a background in Sparklyr, but would there be able to run Carrot on it? The different data mining models through the Carrot library interface.
Sorry, could you repeat the question?
So as far as being able to run Carrot on Spark, like if I'm going to train the way if I do parallel, and I can do a lot of Carrot training on a lot of cores in my PC, can I do that on Spark?
I think the answer I have is I don't know. I mean, I would think that if you can run it on Spark.
I mean, these would be algorithms different than what's in Spark.
Yeah. So I mean, just to recap, Carrot is a library from our community, right? And
yeah, the whole. I mean, one of my value adds for liking R is a huge library of lots of algorithms.
Yeah,
and what's on Spark is much more limited.
Yeah, I mean, Sparklyr doesn't have any particular feature related with Carrot at this moment in time. With the features that are coming, like for instance, the distributed execution of R, you could potentially, and I don't know if this solves your problem, but at least maybe it's worth mentioning, as long as you have a distributed data frame, right, that arrives on each worker node, you could potentially run the Carrot package over it and then somehow aggregate some of the data, right? And I don't know if doesn't seem that it would be that helpful. Seems like more what you'd be looking for is...
if I'm training hundreds of models of different algorithms and they all fit in one server,
right,
and then spread that out horizontally over
it
seems like it'd be naively parallel, but I didn't know if that's supported.
Yeah, no, it wouldn't be supported out of the box. I mean, definitely, I think our approach has been, we're not, at least as part of the Sparklyr package, we're building an interface for Apache Spark, even though, like, as you mentioned, that there's also a need potentially to bring more machine learning models and packages into Spark, right? And I feel like that's like a separate, parallel, approach that we can take. And it's definitely, there's the need there for the community to have better machine learning. I don't have anything, to add to that apart from, it's not supported. But I mean, definitely, it makes sense. I mean, it would be great to have something running, and maybe it can be built on top of Sparklyr. Shoot me an email if you want to explore it in more detail or something. Yeah. Delta row.
Yeah, I also just have a couple other things that are questions / feature requests / comments, because I love where this project is going. But another thing that's great about R that Python and Scala don't necessarily have is matrix multiplication, matrix manipulation, multiplication, right, things like that. So it would be really great if there was some kind of matrix library, specifically sparse matrices. Also, my question is there any functionality for like a C bind or an R bind?
So, for C binding?
C bind or R bind?
Yeah, so to answer the first question, I think what would be really helpful is if you open a GitHub issue and you kind of like explain us like, hey, I would like to do matrix multiplication. Because my guess is that we don't necessarily need to do matrix multiplication in Sparklyr, but my guess is that there's already a good package for matrix multiplication on the Spark community, and all we need to do is create a nice wrapper over the Spark.
There isn't actually, surprisingly. I couldn't find a really good one. Okay. Oh, okay. Oh, I missed that then.
I mean, I would still be interested in having it as a GitHub issue. I mean, I don't know what the answer is, but like I feel like matrix multiplication is a no-brainer and needs to be there, right?
Well, huge matrix multiplication is
huge matrix multiplication. Yeah. Yes.
Okay, so just port it through the Sparklyr interface.
Yeah, no, that's a great suggestion. And for the second question, we do have support for cbind and rowbind that we added on the development version. So it's not available on .5, but if you wanted to append two data frames, you can use it either cbind or rbind, and it would give you the data frame that you expect. Yep.
Okay, thank you.
I think somebody already asked this question. I'm not sure. So this is in reference to the first part. You mentioned there will be a distributed R. The question is how it will be different than the base Spark R, dapply and gapply. And is it gonna be just similar API like other linear regression and SVM, or is gonna be a fundamental different than the Spark R implementation?
So what would be the specific question? Is it what are the difference between Spark R and Sparklyr, or?
No. The distributed R allowing you to run any of the CRAN packages. Spark R already have that function.
Yes. Yeah.
So
no, it
I know
yeah.
Sparklyr also trying to have that. So what's going to be difference with the base Spark R, D-apply and G-apply?
Yeah, I mean, we're definitely not trying, obviously, to have parity with Spark R, right? I mean, I think one of the big principles with Sparklyr was to listen to the R community as much as the Spark community and try to design the interfaces with them together. So there's probably not going to be parity between Sparklyr and Spark R. We definitely want to obviously support distributed execution with package dependencies the way that Spark R also supports. And I mean, I honestly think that in some areas we're going to overlap and it's going to look very similar. In some other ones it's going to be different. I honestly think that there's enough love on the Spark community for having two interfaces that serve different purposes. So, I mean, maybe one day they will unify. I mean, I don't think anyone is opposed to that. But for now, we're just letting them evolve to whatever they evolve each on their own. And we're not trying to have API parity, but definitely functionality-wise, we're trying to, at least from Sparklyr perspective, we want to grow it and implement the functionality that we need the most, right? So definitely, if you have feature requests, open an issue, and I'll do my best to prioritize them and take them into consideration.
Okay. Thank you.
All right, I think it looks like we're out of time. Thank you, Javier, again, for the presentation.
Thank you for having me.